Well, welcome back to our course on system engineering. And in this lecture, we're going to be covering the last section in this design and integration. So this is really a very important part to understand the process of system engineering. And so we did an introduction. We talked about various subjects. We included some development of modeling, talking about SysML. And that's going to be one of the things that we will definitely be doing through this course. And then we have walked systematically through the whole system engineering process. And now we're going to be focusing on an exercise in the system engineering process. And so some of this will go over in a little bit more detail than others, but maybe now by having an example or two, you might actually get a better intuitive sense of what this actually might mean and how you could be using this in your future. So this chapter will provide a comprehensive review. So we'll have a review of chapters 6 through 11, which is a very useful way to complete the course by tying everything together with a simple system. And so unfortunately, they're choosing an automated soda machine. In class, we'll be talking about CubeSats and also a couple other things. And just to have context here, I'd like to continue to be bringing in resources from other of our textbooks. So coming back to the NASA System Engineering Handbook. And so this might be a little bit easier way to see at a high level, the flow of a system and the different milestones that NASA has. And so there's the system design review, the preliminary design review, a critical design review. And so this is when you're ready to actually go about and start to do the production. And then you start to do the production, and then you have the operation and disposal. And you might remember these curves that talk about how much is actually expended in terms of cost, how much is committed, how much is expended. And you can see in the very beginning that it's a very slow progression in how much is actually spent. Production, that's a huge development, it's a huge uptick. And then operation is not nearly as much, but you can have an operational tail that can last a long time. So we're now, once again, getting a reminder, this whole life cycle, and in this chapter, we're going to try and talk about that. So in the SysML Distilled, this textbook that I would recommend, and also getting the resources that are related to that, there's this Dell SAT 77 model, and it's a SysML model that you're able to easily get if you just go to the companion website, lennydelegati.com. Under articles and publications, you can download the model. And here's just an example of one of the views that you can start to be seen from that. So when he was writing the book, I concede for the purpose of writing this book, he came up with this notional satellite system that is fairly well developed. And the more you kick the tires, you'll get some interesting insight. And so this is just a blow up of a high level block definition diagram of the Dell SAT 77 system. And so there's a satellite. Then you can see the various subsystem elements within that satellite: power, attitude control, environmental control, communication and data handling. There's a flight computer and other resources that are here. And there's a relationship between each of these various elements that we're seeing. And then for each of these blocks, you can have, say, that there's parts. So this would be some of the values that you would have that would be associated with each of these blocks. So we're seeing an example of that in the communication and data handling. There's values, and so mass in kilograms, say allocations that are passed on. There's constraints. And so this gets into some of the parametrics and requirements data that would be also called out. And so just a few points that you can start to be thinking about as that flows. So this is, there's a number of ways of having a list of everything that goes on in the system engineering process. Here's just an example of one from Booty. And so first you need to have an external context. You have to define that. You have to define what is in and what is out. And so therefore you need to define the external systems that you're going to have to communicate with. You need to have the usage scenarios. And so it's going to be used in multiple ways. And so you want to architect and define that clearly. You need to have a system diagram. So you start to come up with a system layout. And then you have an objective hierarchy. What are the key requirements, the key performance requirements that are necessary? And then you have the input and output requirements, things that flow in, so you know that you're going to be certain things that you'll get. And then there's needs to be things well-defined of what's going to be flowing out. There's going to be a variety of other requirements that will come into play. And we have spent some time talking about that. And these are more of the functional operational type of requirements. You want to have the fundamental objectives with the weighting schemes. And so when you start to do analysis of alternatives as you go through these things, what are, say, more important than others? And so objectives and the weighting scheme, this is going to be helpful for you when you start to make those next level of detailed decisions in the design and running through the integration and maybe having to do some retrofit of the design. You need to have the test requirements. And so how are you going to validate the system? And then there's the functional architecture, the allocated architecture. So you get into more and more details of the design. You need to have the external items and associated interfaces and the subsystem identification and formulation. So maybe not exhaustive, and you could probably have any handful of similar lists, but that's just a representative one. And so for an operational concept, and so since we're talking about a soda machine, I won't go through this in detail, but chances are every one of us at one time or another have actually bought something from a vending machine, including a soda machine. And so these are the kind of things that would be what you'd have to articulate for what exactly is the operational concept that's supposed to take place when it's operating the way it's supposed to be designed. So you want to be thinking about the external systems that it needs to be working with. And so a patron comes and wants to use a soda machine. And I'm not going to go in detail over into modified into charts, but this is just another way that you can be thinking about that. Here is a more detailed view of a modified N2 chart for all of the usage scenarios. And so this would be something, a way that you would be capturing things that you have in your operational concept and then breaking it on into groups. Here is an IDEF0 diagram showing the external system diagram for the soda machine. The fundamental hierarchy. So you can, I'll just go with the top level. So you have the cost requirements that you want to be pricing it such that people will consume and purchase this. And then the requirements, you want to make sure that it high availability and other things. So it's going to give the correct soda, give the correct change. And so these are all the kind of performance objectives that will be necessary for people to use and to continue to use. This is the other types of input requirements that the soda machine needs to have inventory. It needs to be able to process coins. It needs to be processing patron inputs. And so these are the things that we're starting to show here. And you can see that each requirement has a shall. Each of these is very focused on one topic. They're not overlapping. And so there's a clear way to see that. Here are the output requirements for various types. So there needs to have at least 5 different sodas, a probability of correct change, probability of correct change for a $1 bill, that be able to provide cold sodas to, and so It needs to have a way of having some form of refrigeration, and it just goes on and on. Just we're seeing this list. There's other types of requirements, functional requirements. So the soda machine shall accept change in a soda selection, shall maintain a cold soda. And so it needs to have that ability to maintain. So it needs to be able to have the system at a constant temperature that is ideal for consumption, and then continue to be able to provide the sodas to the patrons and give the change. The external interface requirements, the soda machine shall use electric power, so it needs to be set up in a known environment using standard electricity that would be found in the domain where it would be at. And so here, say in the US, it would be very clear that the type of format, including the type of plug that it would need to have. The soda machine shall use a phone line in the building in which it resides to send status messages. And so that's one possible way in terms of having an external interface to update the owner when they need to be updating or bringing in more inventory for patrons. There can be technology requirements, and so we get into availability, stuff like that. Trade-off requirements, the relative weight of the cost and performance requirements are 0.6 and 0.4. And so cost is a little bit more important than performance. That's the way that they view that. And the performance trade-off requirements, or relative weights of performance requirements, are shown at the right side of the hierarchy. So that's shown in the textbook. And for cost trade-off requirements, the relative weights of cost requirements are also things that are available in the textbook. And here we're showing it on this slide just to give you an idea for both cost and performance, and some of those weighting schemes that would be helpful as you're starting to go through the design and operations. So there's a variety of test requirements, and so you can just be reading through this to get some insight into those types of things that would be used for test requirements, but I'm not going to go through that in detail. And here we're just showing the functional architecture. And so we see how this is going through this general process of it needs to be able to accept change, and soda selection, maintain the cold soda, provide the soda, provide change, and provide status and response to diagnostic test. And so those are the general things that are there. For the allocated architecture, we have a accept change, maintain cold sodas, provide change if necessary, and provide the status. And so those are things that are listed in this IDEF 0 as well. And so just a few thoughts. Once again, we're trying to focus on a specific example, a soda machine, to give us some idea of this process of doing system engineering. Here is a table just showing the external items and the external interfaces. And so these things that would need to be codified for a specific system. And so these are tailored for the things that a soda machine could be using, with a few decisions for exactly how that's going to go about, using an IEEE standard USB port for diagnostics, just as an example of something that we haven't talked about, having an LCD panel that the customer can get feedback because we're trying to negotiate what they want and seeing how much money they put in the machine, et cetera. So at this point, the systems effort has reached a conclusion, provides a basis for creating 5 subsystem teams to begin addressing the 5 subsystems that were identified in the physical architecture and later integrated into the allocated architecture. Patron selection and feedback, chilling, soda extraction, change provider, and status and test. Each team will be given a subsystem, and all the work created at the system level. Each team will then repeat the process described above. So they'll have to come up with an operational concept, internal subsystem diagram, fundamental subsystem objectives, external requirements, subsystem functional architecture, physical and allocated architecture, interface architecture, and integration and qualification for the subsystem. And that's it for this lecture. We've now completed this section on design and integration. So thank you very much.